Somewhere inside your body, hidden within a strand of DNA far too small for the human eye to see, lies a story older than kingdoms, older than language, older even than memory itself. It is not written in ink or carved into stone. It exists quietly inside every living cell, passed from one generation to the next for tens of thousands of years, waiting patiently for science to uncover its meaning. For most of human history, we believed our greatest stories were preserved in ancient ruins, weathered cave paintings, and forgotten civilizations buried beneath the earth. But in recent decades, scientists have discovered that perhaps the oldest history book of all has been with us the entire time. It is carried inside every heartbeat, every breath, and every person alive today. And hidden within that remarkable record is a mystery so astonishing that it challenges everything we think we know about our past. Some geneticists believe there was a time, around 70,000 years ago, when the entire human species came frighteningly close to disappearing forever. Not millions of people, not even hundreds of thousands. According to one interpretation of the genetic evidence, our ancestors may have dwindled to only around 2,000 surviving individuals, scattered across an enormous and unforgiving world, completely unaware that the future of humanity rested upon their survival. If that extraordinary idea is true, then every city ever built, every civilization that ever rose and fell, every language ever spoken, every work of art, every scientific discovery, and every person you have ever known exists because those few survivors endured one of the darkest chapters in human history. But how could scientists possibly know something that happened so unimaginably long ago? What evidence could reveal the size of a population that left behind no written records? And perhaps the greatest question of all, what nearly pushed our species to the edge of extinction? Some researchers point toward an event so immense that it reshaped the planet itself, a volcanic eruption unlike anything humanity has ever witnessed, an explosion so powerful that ash may have darkened the skies, temperatures may have fallen across much of the world, ecosystems were placed under immense stress, and countless living creatures struggled to survive. Yet this story is far from settled. Not every scientist agrees that the eruption nearly wiped out humanity. Others argue the evidence tells a more complicated story, one filled with uncertainty, competing theories, and new discoveries that continue to reshape our understanding of the distant past. Tonight, we will gently follow that ancient trail together. We will explore the clues hidden inside our DNA, journey back to the greatest volcanic eruption of the last 2 million years, examine the scientific debate that still continues today, and discover how a handful of survivors may have shaped the destiny of every human being alive. This is the story of how humanity may have come closer to extinction than we ever imagined, and how that fragile moment may still be quietly written inside us all. Not by exploring forgotten temples buried beneath the desert, not by excavating ancient bones from deep inside caves, not by translating weathered inscriptions carved into stone. Instead, you step into a quiet, brightly lit genetics laboratory, surrounded by microscopes, computers, and machines capable of reading the very code of life itself. Around you, scientists spend countless hours studying tiny strands of DNA, molecules so incredibly small that millions could fit within the width of a single human hair. They were not searching for evidence of a lost civilization. They were not looking for the cause of an ancient catastrophe, and they certainly were not expecting to uncover clues about one of the darkest chapters in the story of our species. Yet, hidden inside every one of us, they found something extraordinary. DNA is often described as the blueprint of life. It determines the color of our eyes, the shape of our faces, and countless other traits inherited from our parents. But it is something far more remarkable than that. It is also history. Not history written with ink upon fragile paper. Not history carved into weathered stone monuments, but history recorded inside living cells, quietly preserved across thousands of generations. Every child inherits DNA from their parents. Their parents inherited it from their own parents, and so the chain continues, stretching backward through grandparents, great-grandparents, and countless ancestors whose names have long since disappeared into the silence of time. Generation after generation, this invisible record has continued to copy itself with astonishing accuracy. Unlike ancient libraries that burn, unlike monuments that crumble, unlike civilizations that vanish beneath sand and soil, DNA remembers. We live on every continent except Antarctica, adapting to deserts, rainforests, mountains, islands, and frozen tundra. Yet beneath all of those visible differences, our DNA tells a surprisingly different story. Compared with many other species, human beings are genetically very similar, far more similar than researchers expected. The differences between two people living on opposite sides of the planet are remarkably small. For scientists, that was deeply puzzling. Normally, a large population accumulates many different genetic variations over time. The larger the population, the more children are born. The more generations pass, the more small genetic changes naturally appear. Those tiny differences slowly build into genetic diversity. It is exactly what researchers observe in many other animals. So why should humans be different? If our ancestors had existed in large numbers for hundreds of thousands of years, why did our DNA contain so little variation? The answer, some scientists suggested, might lie in an event known as a population bottleneck. Imagine a mighty river flowing across a vast landscape, wide, powerful, endless. Then suddenly, the river reaches a narrow canyon. Almost all of the water is forced through a tiny opening. Only a small stream continues its journey. Eventually, the river becomes wide once again. But every drop of water flowing downstream has passed through that single narrow point. According to many genetic researchers, human history may have experienced something very similar. Not a river of water, but a river of people. For reasons still debated today, the number of humans capable of passing their genes to future generations may have fallen dramatically. Scientists have a name for this measurement. It is called the effective population size. This does not represent every person who was alive. Instead, it estimates the number of individuals whose descendants continued into future generations. When researchers used genetic models to estimate that number, they arrived at a result that stunned many of them. Some studies suggested that humanity's effective population size may have fallen to only around 2,000 breeding individuals. Just 2,000. Not millions, not hundreds of thousands, a number small enough to fit inside a modern town. If those estimates are correct, then every person alive today may trace part of their ancestry back through that remarkably small group of survivors. It is one of the most astonishing ideas in modern science. But it also raises an even greater question. DNA can tell us that something extraordinary happened. It can even tell us roughly when it happened. But DNA cannot tell us why. To answer that question, we must leave the laboratory behind, travel back 70,000 years, and step into a world quietly standing on the edge of unimaginable change. Close your eyes for a moment and allow the modern world to quietly fade away. The bright laboratory lights disappear. The computer screens go dark. The glowing strands of DNA slowly dissolve into drifting particles of light until even they vanish into silence. Now imagine time itself beginning to flow backward. Not hundreds of years, not thousands, but tens of thousands. Cities disappear beneath the earth before they are ever built. Roads fade into untouched wilderness. The sound of engines gives way to the distant calls of birds and the whisper of wind moving through tall grasses. Fields of wheat become endless wild plains. Stone castles dissolve into bare mountains. Every monument, every kingdom, every empire quietly slips away. The farther we travel, the quieter the world becomes, until at last we arrive roughly 74,000 years ago. The Earth before history. The Earth before civilization. A world where nature still ruled every horizon. There were no nations, no borders, no written languages, no temples reaching toward the sky, no cities glowing beneath the night. Only rivers carving their patient paths through ancient valleys. Only forests stretching farther than any human could walk. Only endless grasslands dancing beneath the African sun. This was Africa, the birthplace of our species, a continent alive with movement. Golden savannas stretched beyond the horizon, broken only by scattered acacia trees whose flat branches offered precious shade beneath the midday sun. Great rivers wound across the landscape like silver ribbons, feeding marshes rich with life. Dense forests covered the wetter regions, their towering trees sheltering birds whose songs echoed through the morning air. Everywhere, life surrounded our ancestors. Large herds of antelope grazed cautiously across open plains. Zebras wandered together in tightly packed groups, always alert for danger. Massive elephants moved slowly between watering holes, their footsteps leaving deep impressions in the soft earth. Towering giraffes reached effortlessly into the highest branches. Far away, lions rested beneath the shade, conserving their strength for the evening hunt. Hyenas watched patiently from a distance, waiting for opportunity. Above them all, vultures circled silently across the endless blue sky. To modern eyes, it might have appeared like paradise, yet every sunrise carried new challenges. This was not a world of comfort. It was a world of balance. Every creature depended upon another. Every season shaped the rhythm of life. And somewhere among this vast wilderness walked a small group of people remarkably similar to ourselves. They laughed. They worried. They cared for their children. They mourned those they lost. Although separated from us by nearly 75,000 years, they were already fully human. Not the crude caricatures often imagined in old illustrations. Not half-animal creatures stumbling blindly through the wilderness. They possessed curious minds, steady hands, sharp eyes, and hearts capable of deep bonds with one another. Among them is one family. A young hunter rises quietly before dawn. Beside him, his companion gently stirs the fading embers of last night's fire. Their small child still sleeps beneath a simple shelter made from branches, grasses, and animal hides. Nothing about this morning feels unusual. The hunter carefully examines the stone point of his spear, running his thumb along its sharp edge before fastening it securely to a smooth wooden shaft. Nearby, other members of the tribe begin to wake. Soft voices replace the silence of night. Smoke slowly curls upward into the cool morning air. Children rub sleep from their eyes as the first rays of sunlight spread across the savanna. For them, this is simply another ordinary day. As the morning sun climbed higher into the sky, the camp slowly came to life. The younger children remained close to their mothers, laughing softly as they gathered dry branches and smooth stones from the ground. They did not know they were learning. Every small task was a lesson that would one day help them survive. Nearby, an older woman patiently chipped away at a piece of flint with another stone. Each careful strike sent tiny flakes flying through the air until the rough rock slowly became the sharp edge of a new spear point. There were no workshops, no blacksmiths, no written instructions. Knowledge passed from experienced hands to younger eyes, one generation at a time. A few hunters crouched together beneath the shade of an acacia tree, quietly inspecting their weapons before setting out. Spears were straightened, leather bindings were tightened, stone blades were tested against strips of animal hide. Nothing was wasted. Every tool required time. Patience was often the greatest weapon they possessed. Sometimes the hunt ended in success. A well-thrown spear meant food for every family gathered around the evening fire. But many days ended differently. The wind shifted. The animals caught their scent. The herd scattered across the plain in an explosion of dust and pounding hooves. On those days, the hunters simply watched them disappear into the distance. There was no anger, no despair, only the quiet understanding that tomorrow would bring another chance. Back at the camp, life continued just as steadily. Women searched for edible roots hidden beneath the dry earth. They gathered sweet berries when the season allowed, wild fruits, seeds, nuts. Every meal came from careful knowledge of the landscape. Children followed closely behind, learning which plants nourished life and which could bring sickness or death. Long before there were schools, nature itself became the classroom.
The oldest members of the tribe quietly shared memories of distant journeys, successful hunts, changing seasons, and places where water could always be found. Perhaps these were the first stories, perhaps the first lessons, perhaps even the earliest beginnings of human culture. No one can know for certain. But under those stars, something uniquely human was already growing. These communities were small. Most tribes likely numbered no more than 30 or 40 people. Some may have been even smaller. Weeks, or even months, could pass without meeting another group of humans. To us, the world seems crowded. To them, it felt endless. Beyond every distant hill lay another unknown landscape, another river, another forest, another horizon waiting to be explored. Slowly, very slowly, our species continued to spread across eastern Africa. Children became adults. Adults became elders. New families formed. Small groups separated and established new camps beyond the horizon. Generation after generation, humanity's numbers quietly increased. Not rapidly, not dramatically, but steadily enough that hope always belonged to tomorrow. To anyone watching from above, the future might have appeared bright. The seasons still followed their familiar rhythm. The rains returned. The rivers continued to flow. The great herds still crossed the plains. Life, though often difficult, remained beautifully balanced. No one looked toward the horizon with fear. No one sensed that the ground beneath a distant island was slowly changing. No hunter, no mother, no child sitting beside the evening fire. Thousands of kilometers away, beyond the vast Indian Ocean, beyond forests and mountains yet unknown to these early people, beneath what we now call the island of Sumatra, an enormous chamber of molten rock had been gathering strength for thousands of years. Hidden beneath layers of solid earth, pressure continued to build. Silently, patiently, relentlessly. The world above remained peaceful. But deep below, everything was already beginning to change. Thousands of kilometers from the quiet camps of our ancestors, beneath what is now the Indonesian island of Sumatra, the earth had been preparing for a moment unlike almost anything it had witnessed in the last 2 million years. On the surface, nothing seemed unusual. Dense tropical forests stretched across rolling hills. Rivers carved gentle paths toward the sea. Birds called from the towering trees, and countless animals wandered through the warm, humid landscape, completely unaware of what lay hidden far below their feet. Deep beneath the forest floor, beyond the roots of ancient trees, beneath layers of solid rock that had remained undisturbed for countless ages, an enormous reservoir of molten stone slowly shifted in the darkness. This was not an ordinary pocket of magma. It was vast beyond imagination. For thousands of years, molten rock from deep within the Earth's mantle had continued to rise, collecting inside an immense underground chamber. Each new pulse of magma increased the pressure ever so slightly. The chamber grew hotter. The surrounding rock bent under forces too great for the human mind to easily comprehend. Yet the earth remained silent. To anyone standing above, the island appeared perfectly peaceful. The forests continued to grow. Rain continued to fall. Animals continued to hunt, feed, and sleep. Nothing hinted that the ground itself was slowly approaching its limit. When most people imagine a volcano, they picture a steep mountain with glowing rivers of lava spilling down its slopes. Mount Toba was something entirely different. It belonged to an extraordinarily rare class of volcanoes known today as supervolcanoes. Unlike ordinary volcanoes, which release pressure through relatively frequent eruptions, supervolcanoes can spend hundreds of thousands of years quietly storing unimaginable amounts of molten rock beneath the surface. The longer they remain silent, the greater the pressure becomes. And when that pressure can no longer be contained, the eruption is almost beyond comparison. Rather than simply opening a crater near the summit, the ground itself can collapse as the enormous underground chamber empties. Entire landscapes are reshaped. Mountains disappear. Vast calderas, sometimes dozens of kilometers wide, are left behind where solid ground once stood. Scientists believe that the eruption of Toba was among the largest volcanic events our planet has experienced during the last 2 million years. Exactly how large remains the subject of ongoing research. Different studies continue to refine the estimates. But on one point there is remarkable agreement. Whatever happened beneath Sumatra was extraordinary. For thousands of years the pressure continued to build. Tiny fractures spread through the surrounding rock. Invisible gases dissolved within the magma, trapped beneath unimaginable weight. As more molten material entered the chamber, those gases became increasingly compressed, storing enormous amounts of energy. It was rather like air being forced into a balloon. At first, the balloon stretches easily, but with every breath the tension grows. Eventually, there comes a moment when the smallest weakness changes everything. Far below the forests of Sumatra, that moment was approaching. The rocks that had imprisoned the magma for countless generations could no longer bear the strain. Without warning, the earth gave way. What began as a fracture deep underground expanded with astonishing speed. The crack raced through layers of rock faster than any living creature could run. Pressure that had accumulated over thousands of years suddenly found a path toward the surface. The mountain exploded. The sound would have been unlike anything any human, or almost any animal, had ever heard. Not merely loud, overwhelming. A force so immense that the air itself shuddered beneath its power. The ground convulsed violently as unimaginable quantities of gas, ash, and molten rock burst skyward. Within moments, an enormous eruption column surged upward with incredible speed. Hot ash, shattered stone, volcanic gases, and pulverized rock were blasted high above the island, climbing through the atmosphere until the column reached heights that ordinary storms could never approach. Far below, the landscape vanished beneath a storm of fire and ash. Lightning flashed constantly inside the towering cloud as billions of tiny volcanic particles collided with one another. Brilliant forks of white light illuminated the darkness forming overhead. The eruption did not release a single burst of energy and then end. It continued, minute after minute, hour after hour. The earth seemed determined to empty the enormous reservoir hidden beneath Sumatra. Around the volcano, superheated clouds of ash and volcanic gas raced across the landscape at terrifying speed. These deadly currents, known today as pyroclastic flows, hugged the ground as they surged outward, destroying almost everything in their path. Forests disappeared beneath waves of burning ash. Ancient trees that had stood for centuries were flattened, buried, or burned where they stood. Rivers hissed violently as unimaginable heat met flowing water. Entire valleys vanished beneath layers of volcanic debris. Even from great distances the sky began to change. The brilliant blue above Southeast Asia slowly faded behind an expanding veil of gray. Fine volcanic ash continued climbing higher into the atmosphere, where powerful winds carried it far beyond the island itself. Slowly, almost imperceptibly, the cloud began its long journey across the world. The eruption was no longer simply a local disaster. Its effects were reaching outward, carried by the atmosphere itself. Exactly how much ash spread across the globe, exactly how dramatically temperatures changed, and exactly how severely ecosystems were affected, remain subjects of active scientific debate even today. Researchers continue to study volcanic deposits, climate records, and ancient sediments, searching for clearer answers. But there is little doubt that this eruption transformed enormous regions of the Earth. For those living nearby, the world they had known disappeared in a matter of hours. Yet for humanity as a whole, the greatest challenge had not arrived with the explosion itself. It would come afterward, when the ash settled, when the sunlight faded, when food became scarce, and when survival itself would be tested in ways no human had ever experienced before. The eruption was only the beginning. When the violence of the eruption finally began to fade, it might have seemed as though the worst had passed. The deafening explosions grew quieter. The towering column of ash slowly lost its furious momentum. The rivers of fire cooled into silent stone. Across the shattered landscape surrounding Mount Toba, an eerie stillness settled over the land. But the eruption had not truly ended. In many ways, its greatest consequences were only beginning. High above the Earth, billions upon billions of tiny volcanic particles continued to drift through the atmosphere. Unlike ordinary dust, these microscopic fragments were light enough to remain suspended for months, perhaps even years, carried by powerful winds far beyond the island where the eruption had begun. The cloud spread slowly across Asia, then farther still. It drifted over mountains, forests, rivers, and seas, reaching places where no human could have imagined the volcano existed. The people living thousands of kilometers away never heard the explosion. They never saw the mountain collapse. Yet the sky above them was quietly beginning to change. The brilliant blue that had greeted countless generations slowly became pale and hazy. Each sunrise appeared a little weaker than before. Each sunset lingered behind a veil of gray. The change was almost impossible to notice from one day to the next. But nature notices even the smallest differences. Sunlight is far more than warmth. It is the energy that powers nearly every living thing on Earth. Every blade of grass, every towering tree, every flowering plant, all depend upon sunlight to create the food that keeps them alive. When less sunlight reaches the ground, the entire foundation of life begins to weaken. Scientists continue to debate exactly how much the global climate changed after the Toba eruption and for how long those effects lasted. Different models offer different estimates, and new evidence continues to refine our understanding. Yet many researchers agree that large volcanic eruptions can reduce the amount of sunlight reaching Earth's surface, leading to periods of cooler temperatures and significant environmental stress. For the natural world, even a modest shift could be profound. Growing seasons became shorter. Some plants struggled to recover. Forests in certain regions may have grown more slowly. Grasslands that once supported enormous herds became less productive. The change was uneven. Some places suffered greatly. Others remained comparatively stable. Nature rarely responds in exactly the same way everywhere. But uncertainty itself became a new challenge. Rainfall patterns began to shift. Some rivers that had flowed reliably through countless seasons became shallower. Small lakes shrank beneath unfamiliar skies. Waterholes that generations of animals had depended upon no longer offered the same security. Across the landscape, the great migrations began to change. Herds of antelope moved farther in search of fresh grazing. Elephants wandered across greater distances, following the scent of distant water. Zebras abandoned familiar routes. Even the great predators were forced to adapt. Where the herbivores traveled, the hunters followed. The balance that had guided life for thousands of years was slowly unraveling. Food chains do not collapse all at once. They weaken one link at a time. When grasses become scarce, the grazing animals struggle. When grazing animals decline, predators must travel farther to find food. When predators compete more fiercely, every hunt becomes more dangerous. The effects ripple outward, touching every living creature connected to that fragile web of life. For our ancestors, the changing world brought new uncertainty with every passing season. The familiar landscape no longer behaved as it once had. Places that had always provided food suddenly offered very little. Fruit ripened less predictably. Edible roots became harder to find. Animals appeared later than expected, or not at all. Each successful hunt demanded more patience, more distance, more risk. Small tribes found themselves traveling farther between camps than ever before. The journey that once took a single day might now require several. Children grew tired more quickly. The elderly struggled to keep pace. Every decision became more important. Should the group remain where they were and hope conditions improved? Or should they leave behind everything familiar in search of a better place they could not even be certain existed? No one possessed maps. No one knew what lay beyond the next valley. Every step into the unknown carried equal measures of hope and danger. Some groups likely found new rivers. Others may have discovered valleys where plants continued to flourish despite the changing climate. But many were surely less fortunate. A failed hunt, a dried-up waterhole, an unusually cold season. Each hardship alone might be survivable. Together they could become overwhelming. Parents would have eaten less so their children could eat more. Hunters would have walked farther than ever before. Elders carried generations of knowledge, desperately searching their memories for places where water had once been plentiful during difficult years. Cooperation became more valuable than strength. Sharing became more important than competition. Survival was no longer simply about finding food. It was about helping one another endure another day, another week, another season. The world had not ended, but it had become far less forgiving. Across Africa and beyond, countless small human communities faced the same quiet struggle. Most would never meet one another. They would never know that people hundreds or even thousands of kilometers away were facing remarkably similar hardships beneath the same dim sky. Each tribe believed it was fighting its own battle against an increasingly unpredictable world. Yet together, they were living through one of the greatest environmental challenges our species may ever have experienced. Some groups disappeared. Their stories ended without leaving names, without leaving monuments, without leaving written memories. Only silence remained where they had once lived. But not everyone was lost. Scattered across the vast landscapes of Africa, a handful of remarkably resilient communities adapted, moved, shared, endured, and continued carrying humanity's future into the next generation. A few small groups somehow endured. As the world grew colder and less predictable, survival became something far more fragile than it had ever been before. Humanity was never spread evenly across the landscape. Even before the environmental changes that followed the Toba eruption, people lived in small, scattered bands. A single group might consist of only a few families, perhaps 20, 30, or 40 individuals who depended completely upon one another. They possessed no cities, no farms, no stored harvests waiting for difficult seasons. Everything they needed had to be found in the world around them, day after day. Now that world had become far less generous. Each morning began with uncertainty. Would there be animals to hunt? Would the fruit trees still bear food? Would yesterday's waterhole still contain water? No one could know until they arrived. A successful hunt no longer guaranteed another tomorrow. Some days ended with full stomachs. Others ended with hungry children falling asleep beside dying campfires while their parents quietly pretended they were not hungry themselves. Hunger became a constant companion. It was not always the desperate starvation that arrives suddenly after a disaster. More often it was quieter than that. Meals became smaller. Hunting journeys became longer. Food that had once been ignored suddenly became valuable. Nothing useful could be wasted. Bones were broken open to reach the nourishing marrow hidden inside. Seeds were collected. Roots were dug carefully from hard ground. Even insects, eggs, and small reptiles may have become important sources of nutrition whenever larger prey disappeared. Every calorie mattered. For countless generations our ancestors had learned to read the landscape with remarkable skill. A broken branch could reveal the path of an antelope. Fresh footprints in soft mud could lead to water. The movement of birds overhead might reveal a hidden lake beyond the hills. Those skills now became even more important. Nature still offered opportunities. They were simply harder to find. Some researchers have proposed that certain groups of early Homo sapiens may have survived these difficult conditions by remaining close to the coast. This idea, often called the coastal refuge hypothesis, suggests that shorelines may have provided a more reliable supply of food even while inland environments became increasingly unpredictable. Unlike migrating herds, the ocean followed rhythms of its own. Each tide revealed a different landscape. Rock pools trapped fish. Shellfish clung to exposed rocks. Crabs hid beneath stones. Seaweed washed ashore. These resources required patience more than strength. A family did not need to chase a gazelle across miles of open grassland to gather shellfish. Children, adults, and elders could all contribute, slowly collecting food together as the tide retreated. For groups fortunate enough to live near the coast, the sea may have offered something increasingly rare: consistency. Scientists continue to debate exactly how important coastal resources were during this period, and different regions almost certainly experienced different conditions. Yet archaeological evidence from parts of southern Africa suggests that some early humans made extensive use of marine foods, including shellfish, long before the rise of agriculture. Whether this became humanity's greatest refuge or simply one of several successful survival strategies remains uncertain. But the idea reminds us of something important. Human beings survived not because they were the strongest animals on Earth. They survived because they adapted. Adaptation often began with the simplest of ideas: a sharper stone, a stronger wooden spear, a better way to carry water, a more efficient method for preparing food. Small improvements, almost invisible on their own, could make an enormous difference when every meal mattered. Innovation did not arrive all at once. It accumulated slowly, one careful observation after another. Someone discovered a better way to shape a stone blade. Another found that certain types of wood produced stronger spear shafts. Someone else learned which plants remained edible even during difficult seasons. Knowledge became one of humanity's greatest resources. Unlike food, it could be shared without being consumed. Every lesson taught to a child increased that child's chance of surviving adulthood. Every successful hunting technique passed to another family strengthened the entire group. Cooperation became more valuable than ever before. A single hunter could fail. Several hunters working together had a greater chance of success. One parent alone could struggle to protect a child. An entire community could watch over every child together. Food was shared. Tools were shared. Experience was shared. Even grief was shared. When one family suffered loss, the burden did not have to be carried alone. Strong social bonds may have become just as important as sharp spears. Children represented something more valuable than additional mouths to feed. They represented the future. Every child who survived carried the possibility that humanity itself would continue. Parents endured hunger so their children could eat. Grandparents, with decades of accumulated knowledge, taught younger generations where to search for water, how to recognize dangerous animals, and which plants could be trusted when little else remained. Around small campfires beneath unfamiliar skies, stories, skills, and survival itself passed quietly from one generation to the next. It is impossible to know exactly how many communities disappeared during those difficult centuries. Many left no trace that time has preserved. Others may yet remain hidden beneath layers of earth, waiting to be discovered. What we do know is that some groups survived. They adapted to changing environments. They cared for one another. They continued raising children despite uncertainty. And through their resilience, the human story continued. Yet not every scientist believes Toba nearly wiped us out. For generations, the story seemed almost complete. Human DNA appeared to preserve the memory of an extraordinary population bottleneck. The eruption of Mount Toba stood as one of the largest volcanic events of the last 2 million years. The timing seemed remarkably close. A massive eruption. A dramatic reduction in human genetic diversity. A species that somehow survived. For many researchers, the pieces appeared to fit together. It was an elegant explanation. Perhaps too elegant. Science has a curious habit of becoming more complicated the closer we look. Every new discovery answers one question, while often creating two more. The idea that the Toba supereruption nearly drove humanity to extinction first gained widespread attention because of genetic evidence. When researchers began studying human DNA in greater detail, they found something remarkable. Compared with many other mammals, humans possess surprisingly little genetic diversity. Whether someone lives in Africa, Europe, Asia, Australia, or the Americas, the differences written inside their DNA are astonishingly small. Far smaller than scientists once expected from a species spread across nearly every corner of the planet. That discovery demanded an explanation. One possibility was that humanity had once passed through an extremely small population. If only a limited number of individuals survived during some distant period, then only their genetic variations would continue into future generations. Everything else would simply disappear. It is rather like copying a book. Imagine a library containing thousands of different editions of the same story. Now imagine that almost every copy is destroyed. Only a handful remain. Every future copy must now be reproduced from those few surviving books. Many of the original differences are gone forever. Some genetic models suggested that something similar may have happened to our own species around 70,000 years ago. Using mutation rates and patterns of inherited DNA, researchers estimated an effective breeding population that may have fallen to only a few thousand individuals. Some estimates suggested around 2,000. Others proposed somewhat larger numbers. The exact figure varies depending upon the methods used. But many studies pointed toward the same general conclusion. At some point in our distant past, humanity appears to have become remarkably small. Then researchers looked at the calendar. Roughly 74,000 years ago, Mount Toba erupted. The timing seemed difficult to ignore. A volcanic catastrophe capable of altering climate, followed by genetic evidence suggesting a severe population decline. To many scientists, the connection appeared both logical and persuasive. Yet science is rarely settled by a single line of evidence. As archaeologists continued excavating ancient sites across Africa and Asia, new discoveries began raising uncomfortable questions. One of the most important came from the Indian subcontinent. At a place known today as Jwalapuram, archaeologists uncovered stone tools buried both beneath and above the layer of volcanic ash left behind by the Toba eruption. The finding was remarkable. If the dating is correct, it suggests that humans occupied the region before the eruption and continued living there afterward. Rather than disappearing completely, at least some communities appear to have endured. The eruption may have disrupted their lives dramatically, but it may not have erased them. Other archaeological sites have offered similar reasons for caution. Instead of evidence for a sudden collapse across every region, some locations suggest remarkable continuity. People continued making tools. They continued hunting. They continued adapting to changing environments. This does not necessarily disprove a population bottleneck, but it does suggest that the story may be far more complicated than originally imagined. Climate scientists have also contributed important new perspectives. Early versions of the Toba catastrophe theory proposed that enormous quantities of volcanic ash and sulfur entered the atmosphere, triggering a severe volcanic winter across much of the planet. More recent climate models, however, suggest that the cooling may not have been equally intense everywhere. Some regions may indeed have experienced dramatic environmental stress. Others may have remained comparatively stable. Rainfall patterns differed. Vegetation responded differently from one landscape to another. Local geography may have protected certain ecosystems while exposing others to much harsher conditions. If that is true, then humanity's experience of the eruption would not have been identical across the world. Some groups may have faced extraordinary hardship. Others may have found refuges where survival remained possible. Rather than one single global disaster affecting everyone equally, the reality may have been a patchwork of very different experiences unfolding across thousands of kilometers. This growing body of evidence has led many researchers to ask a different question. Perhaps Mount Toba did not create the bottleneck. Perhaps it intensified changes that had already begun. Or perhaps the genetic bottleneck resulted from several difficult periods spread across thousands of years rather than one catastrophic event alone. At the moment, science cannot answer that question with complete certainty. And that uncertainty is not a weakness. It is one of science's greatest strengths. Scientific knowledge is never carved into stone. Every new fossil, every ancient campsite, every improved climate model, every advance in genetic sequencing, has the power to reshape our understanding of the past. Ideas are constantly tested. Evidence is questioned. Old conclusions are refined. Sometimes they are confirmed. Sometimes they are replaced. That is how our understanding grows. The story of Toba is therefore not simply a story about volcanoes or ancient humans. It is also a story about discovery itself. About researchers working across genetics, archaeology, geology, and climate science, each contributing a different piece of an enormous puzzle that is still incomplete. Perhaps future discoveries will strengthen the case for a catastrophic bottleneck. Perhaps they will reveal an entirely different explanation. For now, the evidence continues to point toward one undeniable truth. Something extraordinary happened during this chapter of human history. Exactly what happened, and exactly why, remain among the most fascinating questions scientists continue to explore. Whether or not Toba caused the bottleneck, humanity changed. The people who survived those difficult years did far more than preserve their lives. Whether the Toba eruption caused humanity's genetic bottleneck or simply occurred during a period of profound environmental change remains one of the great scientific debates. But another fascinating question has emerged alongside it. Did hardship itself help shape the modern human mind? It is an idea that has captured the imagination of many researchers. Not because catastrophe magically transformed our ancestors overnight, but because difficult environments often reward new ways of thinking. Imagine living in a world where food had become unpredictable, where familiar hunting grounds no longer guaranteed success, where rivers shifted, seasons changed, and every journey carried uncertainty. In such a world, physical strength alone may not have been enough. Survival increasingly depended upon something else: the ability to work together. Humans had almost certainly cooperated long before this period. Our ancestors hunted together, shared food, and protected one another for hundreds of thousands of years. Cooperation was not a new invention. But under greater environmental pressure, its importance may have grown dramatically. A single hunter could fail. A coordinated hunting party had far greater chances of success. One family struggling alone might disappear. Several families sharing food, knowledge, and responsibility could endure far longer. The strongest communities were not always those with the strongest individuals. Often they were those whose members trusted one another the most. Communication became increasingly valuable. Simple gestures and calls had always existed. But some researchers have suggested that growing environmental challenges may have encouraged the development of more sophisticated language. This remains a hypothesis rather than an established fact. Language leaves no fossils. No ancient sentence survives from 70,000 years ago. Scientists must instead rely on indirect evidence drawn from archaeology, genetics, and comparisons with living humans. Even so, the possibility is fascinating. Clearer communication allows groups to coordinate hunts, to warn of danger, to describe distant water sources, to teach children more effectively. The more precisely information can be shared, the greater the chances that an entire community survives. Planning may also have become increasingly important. When food is abundant, tomorrow requires relatively little thought. But when resources become uncertain, every decision carries greater weight. Should the group remain near the river? Should they follow migrating animals? Should food be shared today or saved for tomorrow? These choices required looking beyond the present moment. Some researchers believe that increasingly complex planning may have become one of humanity's greatest advantages during periods of environmental stress. Another intriguing possibility involves symbolic thought. Modern humans constantly use symbols. Words represent ideas. Paintings represent stories. Objects carry meaning beyond their physical form. Exactly when this ability emerged remains uncertain. Some archaeological discoveries suggest that symbolic behavior appeared gradually over many thousands of years rather than suddenly at one specific moment. Others argue that periods of hardship may have accelerated its development. At present, the evidence cannot provide a definitive answer. Yet symbols possess remarkable power. They allow people to remember ideas, to strengthen group identity, to pass traditions from one generation to the next. Perhaps even more important than individual intelligence was humanity's ability to learn from one another. No single person needed to discover everything alone. One hunter learned a better way to shape a spear. Another discovered a safer migration route. Someone else identified a new edible plant growing after seasonal rains. Those discoveries did not disappear when shared. Instead, they multiplied. Knowledge became a resource unlike any other. The more was exchanged, the stronger the community became. Scientists call this process social learning. It is found in many animals to varying degrees. But in humans it reached extraordinary levels. Children did not simply imitate their parents. They learned from grandparents, from skilled hunters, from experienced gatherers, from every member of the group. Each generation began life with the accumulated knowledge of the one before it. That process created something even more remarkable: culture. Culture is more than art or music. It is the collection of skills, beliefs, traditions, and knowledge passed from one generation to another through learning rather than genetics. Unlike DNA, culture can change within a single lifetime. A useful innovation discovered today can spread throughout an entire community tomorrow. A better hunting technique, a more effective stone tool, a safer campsite, a new way of preparing food. Every successful idea could become part of humanity's growing cultural inheritance. Many researchers believe that this ability to preserve and transmit knowledge became one of our species' greatest evolutionary advantages. Others caution that these developments likely unfolded gradually over tens of thousands of years rather than emerging from one single crisis. The archaeological record does not point toward one dramatic turning point. Instead, it reveals a slow accumulation of innovation, creativity, and increasingly sophisticated behavior across many regions and many generations. Perhaps environmental challenges encouraged that process. Perhaps they simply rewarded abilities that had already begun to develop. Or perhaps several different forces acted together. Climate change, population movements, social interaction, natural selection, cultural innovation, each influencing the others in ways we are only beginning to understand. Science has not yet reached a final answer, and perhaps it never will. The distant past rarely offers complete certainty. Instead, it gives us clues, fragments, patterns waiting to be interpreted with care. What seems increasingly clear is that humanity's greatest strength was never simply intelligence alone. It was the ability to learn together, to adapt together, to remember together. While stronger animals relied upon sharper claws or larger teeth, our ancestors carried something far more powerful: shared knowledge, shared experience, shared hope. Whatever hardships they faced them as communities, and because they did, their story did not end beneath darkened skies or cooling climates. It continued. From these survivors, a remarkable journey began. The world did not recover in a single season. There was no morning when the skies suddenly cleared forever, the rivers instantly filled once again, or the great herds returned exactly as they had been before. Recovery came quietly, almost unnoticed. One generation survived a little more easily than the one before. A valley that had once struggled to support life slowly grew green again. Grass returned to open plains. Trees spread fresh leaves beneath warmer skies. The rhythm of the seasons gradually became more familiar. Nature was healing. And with it, so was humanity. The small groups that had endured the hardest years slowly found themselves living in landscapes that were becoming more generous. Animals became easier to find. Water sources grew more dependable. Edible plants appeared more regularly throughout the changing seasons. Life remained challenging, but it no longer demanded quite the same desperate struggle every single day. For the first time in many generations, some families were able to think about more than simply surviving until tomorrow. Children who once faced constant uncertainty now had a greater chance of reaching adulthood. More children survived. More families grew. More camps appeared across the landscape. Little by little, the human population began to increase. The growth was almost unimaginably slow. There were no cities, no villages, no fields of grain. Human communities still lived as hunters and gatherers, following the movements of animals and the changing availability of wild plants. Yet compared with the difficult centuries that may have followed the great environmental crisis, the future was beginning to look more hopeful. As populations slowly expanded, people encountered one another more often. Small bands that had once lived in near isolation occasionally crossed paths during seasonal migrations. Sometimes they exchanged knowledge. Sometimes they shared food. Sometimes new families formed as individuals joined neighboring groups. Every meeting created opportunities for ideas to spread. Knowledge no longer remained trapped inside a single camp. A better way of shaping a stone blade could travel from one community to another. A more effective hunting strategy could be observed, remembered, and repeated. New methods for preparing food or building temporary shelters gradually spread across larger regions. Innovation did not depend upon one extraordinary invention. It grew through countless small improvements accumulated across many generations. Stone tools became more carefully crafted. Sharp cutting flakes were produced with greater precision. Wooden spears became stronger and more reliable. People learned which raw materials created the most durable tools and where those valuable stones could be found. Each improvement made survival just a little easier than before. Cooperation also continued to grow in importance. Larger groups could organize more successful hunts. They could care for children together. They could protect elderly members whose experience remained invaluable. Knowledge became one of humanity's greatest treasures. Unlike food, it did not disappear when shared. Every lesson taught strengthened the next generation. Every successful idea increased the chances that an entire community would thrive. Social bonds grew stronger as communities became slightly larger and more connected. Trust allowed strangers to become allies. Families became networks. Networks slowly became populations. This process unfolded over thousands of years. There was no sudden transformation. No single moment when humanity became modern. Instead, countless generations built patiently upon the achievements of those who came before them. Each child inherited not only the DNA of their ancestors, but also their skills, their experience, their traditions, and their growing understanding of the world. As the climate gradually stabilized, opportunities began appearing beyond familiar territories. Some hunting grounds became crowded. Young families searched for new places where food remained plentiful. Exploration became part of survival. Small groups followed rivers into unfamiliar valleys. Others crossed open grasslands that earlier generations had rarely visited. Some reached coastlines where marine resources offered dependable food. Others climbed into highlands or moved through forests in search of better opportunities. No one believed they were changing the course of history. Each journey was made for simple reasons: to find water, to follow migrating animals, to give children a better chance of survival. Yet together, these countless small journeys slowly expanded the human presence across Africa. The continent that had nurtured our species for hundreds of thousands of years was becoming increasingly familiar to its people. Its rivers were explored. Its grasslands were crossed. Its mountains were climbed. Its coastlines revealed new possibilities. Generation after generation, humanity became more adaptable, more knowledgeable, more connected. The survivors who had once struggled through one of the most uncertain chapters in human history had done more than simply preserve their existence. They had laid the foundation for everything that would come next. Without realizing it, they were preparing their descendants for the greatest journey our species would ever undertake. A journey that would carry humans beyond the continent where they first evolved, into landscapes no human had ever seen. The descendants of those survivors would eventually leave Africa. For hundreds of thousands of years, every human life had unfolded within a single continent. Africa was not simply humanity's birthplace. It was humanity's entire world. Its rivers, forests, grasslands, mountains, and coastlines had shaped countless generations of our ancestors. Every lesson they learned, every tool they crafted, every child they raised belonged to a story written entirely upon African soil. But slowly, almost imperceptibly, that story began to expand. No one woke one morning and decided to leave a continent forever. There was no great expedition, no map, no destination waiting beyond the horizon. Instead, countless small journeys unfolded across thousands of years. A family followed migrating animals a little farther than their parents had. Another group discovered fresh water beyond a distant valley. Others explored unfamiliar coastlines where fish and shellfish provided dependable food. Each journey was made for simple reasons: to survive, to find food, to protect children, to seek a better future. Yet together, those countless small decisions became one of the greatest migrations in the history of life on Earth. Around 70,000 years ago, or perhaps somewhat later according to different archaeological evidence, groups of Homo sapiens gradually began moving beyond Africa. Scientists continue to debate the precise timing and the exact routes these early migrations followed. New discoveries regularly refine our understanding. But the broader story remains remarkably clear. Our ancestors expanded into lands no human had ever permanently inhabited before. Some followed coastlines bordering the Red Sea and the Arabian Peninsula. Others slowly spread across the vast landscapes of Western Asia. Generation after generation, they adapted to unfamiliar climates, new animals, and entirely different environments. The journey did not happen quickly. It unfolded over thousands of years. Children were born. Grandparents grew old. Entire generations lived and died while the migration continued. Slowly, humanity reached the forests and grasslands of Asia. Some communities settled near great rivers. Others crossed mountains that earlier generations had never imagined. As populations gradually expanded, new paths opened farther north and east. Eventually, humans entered Europe. There they encountered colder climates unlike anything many of their ancestors had experienced before. Ice covered large portions of the landscape during different periods. Winter demanded new skills, warmer clothing, better shelters, more careful planning. Human beings adapted once again. Far to the southeast, another extraordinary journey unfolded. Early Homo sapiens eventually reached Australia, crossing stretches of open water that separated the continent from Southeast Asia. Exactly how these crossings were achieved remains an active area of research. Simple watercraft may have played an important role. Whatever the method, reaching Australia required planning, cooperation, and remarkable courage. It stands among the greatest achievements of prehistoric exploration. Thousands of years continued to pass. Human communities spread farther across Asia. Eventually they reached the northeastern edge of the continent. Much later, during periods when lower sea levels exposed land connecting Siberia and North America, some groups crossed into an entirely new world. These pioneering communities became the ancestors of the first peoples of the Americas. From the frozen Arctic, to dense tropical forests, to towering mountain ranges, humanity continued adapting wherever opportunity appeared. Every environment demanded new solutions, new tools, new knowledge, new traditions. Yet beneath all those differences, something remarkable remained unchanged. Every one of those travelers belonged to the same species. Every child inherited the same remarkable genetic history carried by generations before them. Whether their descendants settled in Europe, Asia, Australia, or the Americas, their ancestry ultimately stretched backward through Africa. And if the genetic bottleneck theory is correct, then that ancestry also passed through one extraordinarily small population that survived one of the most uncertain chapters in human history. Today, nearly every landscape on Earth bears the imprint of those ancient journeys. Cities rise where grasslands once stretched endlessly. Roads cross valleys where mammoths once wandered. Ships sail oceans that our ancestors first viewed from distant shorelines. Airplanes now connect continents that once required thousands of years to reach on foot. Human cultures have become wonderfully diverse. Thousands of languages are spoken. Countless traditions have emerged. Different histories have shaped different civilizations. Yet beneath every visible difference, our DNA quietly tells the same ancient story. The differences between people living on opposite sides of the world remain astonishingly small. Because no matter where our families live today, our story began together. Every nation, every culture, every community, every family tree, all are branches of the same remarkable human journey. The paths eventually spread across every continent except Antarctica, but their roots remained deeply connected. The descendants of those ancient survivors became explorers, hunters, artists, builders, farmers, sailors, scientists, and eventually, the greatest evidence of that journey is still inside us. As our journey slowly comes to an end, we return to where it first began. Not to an ancient volcano, not to a forgotten landscape buried beneath layers of ash, but to something far closer. Your own body. Hidden inside nearly every cell you possess is a strand of DNA that has traveled an almost unimaginable distance through time. It has passed from parent to child, from generation to generation, across tens of thousands of years. It has survived changing climates, long migrations, countless hardships, and perhaps one of the greatest population crises our species has ever faced. Whether humanity truly fell to only around 2,000 breeding individuals remains an active question in science. Researchers continue to debate the evidence, refine genetic models, uncover new archaeological discoveries, and improve our understanding of ancient climates. The story is still being written, and that is exactly how science should work. Each new discovery brings us a little closer to understanding the distant past. Some ideas grow stronger. Others become more complicated. Some are replaced entirely. The search for truth never truly ends. Yet despite those remaining questions, one remarkable fact stands beyond dispute. Human beings possess surprisingly little genetic diversity. Compared with many other species spread across similar ranges, we are extraordinarily alike. The differences we notice so easily in everyday life, skin color, hair texture, eye shape, height, facial features, represent only a tiny fraction of the story written inside our DNA. Beneath those visible differences, we are astonishingly similar. Every person alive today belongs to one remarkably connected family. Our ancestors followed different paths across the earth. Some crossed deserts, others climbed mountains. Some settled tropical forests, others survived frozen tundra. Over thousands of years they built different cultures, spoke different languages, worshipped in different ways, and imagined the world through countless unique traditions. Yet none of those journeys erased our shared beginning. Every family tree eventually reaches the same ancient roots. That quiet connection reminds us of something deeply important. Human history is not simply a story of survival. It is a story of resilience, Again and again our ancestors faced uncertainty. Ice ages, droughts, changing climates, volcanic eruptions, new landscapes, unknown dangers. Again and again, they adapted, they learned, they cooperated, they cared for one another. Their greatest strength was never speed, nor size, nor physical power. It was the extraordinary ability to solve problems together and to pass those solutions from one generation to the next. Knowledge became inheritance. Compassion became survival. Hope became tradition. Every child carried not only the DNA of those who came before, but also their experience, their courage, and their determination to continue. Perhaps that is the greatest legacy they left behind. Not monuments carved from stone, not written records preserved in libraries, but a living inheritance carried quietly inside every human being. An invisible thread connecting billions of strangers across every continent. A reminder that no matter where we live today, our story has always been shared. The people who walked beneath unfamiliar skies 70,000 years ago could never have imagined the world that would one day exist. They never knew cities would rise. They never dreamed that ships would cross oceans, or that machines would fly above the clouds. They could not have imagined music recorded forever, books carried inside tiny computers, or human beings looking back toward the stars from the surface of the moon. They only knew one simple truth: survive today, protect the children, help one another, keep moving forward. Everything that followed grew from those quiet decisions. Every heartbeat, every family, every civilization may exist because a tiny group of exhausted people refused to disappear. And perhaps, somewhere inside every strand of DNA we carry today, their quiet determination still journeys with us, not as a memory we can consciously recall, but as a silent reminder that even in humanity's darkest moments, hope has always found a way to endure. Thank you for joining me on tonight's journey. And as the story gently fades into the quiet distance, may it leave you with one comforting thought. No matter how different we may appear, we have always been part of the same human story.